Hello everyone, welcome back to my channel inphuseclab. Today we're going to continue our series on TryHackMe's web app and testing, and the topic is going to be insecure deserialization. Now, don't worry if you don't know what deserialization means. In this room, we'll go over what deserialization is and how it is used in modern web applications, and we're going to learn some vulnerabilities associated with insecure deserialization. Without further ado, let's get started. Introduction. User supply input has consistently been a catalyst for vulnerability, posing persistent threats across numerous platforms and applications. Exploiting user input from SQL injection to cross-site scripting is a well-known challenge in securing web applications. Another less understood but equally dangerous vulnerability associated with user input is insecure deserialization. Insecure deserialization exploits occur when an application trusts serialized data enough to use it without validating its authenticity. This trust can lead to disastrous outcomes as attackers manipulate serialized objects to achieve remote code execution, escalate privileges, or launch denial of service attacks. This type of vulnerability is prevalent in applications that serialize and deserialize complex data structures across various programming languages, such as Java, .NET, and PHP, which often use serializations for remote procedure calls, sections management, and more. The learning objective is to learn how the serializations and deserialization process work, the potential risks to the web applications, the exploitation techniques, and some mitigation measures. Again, as usual, some learning prerequisites. You should learn how the website works, the protocols and servers, and the OWASP 10. And before we move on, let's start our attacking machine and the target machine. Alright, some important concepts. Let's complete this question. Before discussing insecure deserialization in detail, it's crucial to understand the basic concept through a simple example. Serialization. Think of serialization like packing your school bag in the morning. You have books, notebooks, a lunchbox, and a water bottle, which you need to organize into your bag. Serialization is just like taking different pieces of information, like notes, and putting them together to make them easy to store or send to a friend. In programming, serialization is a process of transforming an object state into human-readable or binary format that can be stored or transmitted and reconstructed as when they need it. This capability is essential in applications where data must be transferred between different parts of the system across a network, such as a web-based application. In PHP, this process is performed using the serialize function. And this is a simple code to serialize an object, the data. The following output shows the serialized string in a node.txt file, which includes the details of the node structure and content. It's stored in a way that can be easily saved and transmitted. For now, don't worry about this. As we continue our readings, we will dive into what the output is and how to read them. Deserialization. Imagine you arrive at school and you need everything in your bag this morning. Deserialization is like unpacking your school bag when you get to class. You check out each item so you can use it throughout the day. As you unpack your bag to get your books and lunch, deserialization packs up data and turns it back into something you can use. Deserialization is a process of converting the formatted data back into an object. It's crucial for retrieving data from files, databases, or across networks, restoring it to its original state for usage in applications. And this is a piece of code where we deserialize the data. This code reads the serialized form of file and convert it back to an array, effectively reconstructing the original node. Discussing serializations also necessitates a conversation about security. Like, you wouldn't want someone to put your school bag. Insecure deserializations can lead to significant security vulnerabilities in software applications. Attackers might alter serialized objects to execute unauthorized actions or steal data. There are some specific incidents involving serialization vulnerabilities. Let's discuss some of these. Log4J vulnerability, CVE 2021, 44-28. Log4J vulnerability, or known as Log4Shell, is a critical security found in the Apache Log4j library, a widely used library in Java applications. The vulnerabilities allow remote attackers to execute arbitrary code on the system by exploiting the library's insecurity functionality. If you want to learn more about this vulnerability, check out the Explain for Log4j room. So TryHackMe actually has a room for this one. which we're going to skip for now, but we may come back later. The impact. The vulnerability facilitated remote code execution, enabling attackers to execute arbitrary commands on affected system. This allowed attackers to compromise critical infrastructures, leading to unauthorized access to sensitive data, service disruptions, and potential supply chain attacks. WebLogic Server Remote Code Execution, CVE 2015-4852. The incident was related to the Oracle WebLogic server. Deserialized data was sent to the T3 protocol. Attackers could send malicious corrupted objects to the server, which then, when deserialized, led to remote code execution. This vulnerability was widely exploited to gain unauthorized access to systems, deploy ransomware, or steal data. It affected all versions of WebLogic server that had not disabled the vulnerable service or patched the issues. Jenkins Java Deserialization CVE 2016-0792. Jenkins, a popular automation server used in software development, experienced a critical vulnerability involving Java deserialization. Attackers could send corrupted deserialization payloads to Jenkins CLI, which, when deserialized, could allow arbitrary code execution. This allowed attackers to execute shell commands, potentially taking over Jenkins server, which often had broad access to software development environments, including source code, build systems, and potentially deployment environments. Alright, let's answer some questions. What's the function used in PHP for serialization? Serialize. What is the base core of the vulnerability CV 2015-4852? Let's take a look. 7.5. Does serializations allow only saving to a byte stream file? No. It can be anything. Okay. Serialization formats. While different programming languages may use varying keywords and functions for serialization, the underlying principle remains consistent. As we know, serialization is a process of converting an object state into a format that can be easily stored or transmitted and then reconstructed later. Whether Java, Python, .NET, or PHP, each language implements serialization to accommodate specific features or security measures inherent to its environment. Unlike other common vulnerabilities that exploit the immediate process of user inputs, serialization problems involve a deeper interaction with the application's logic, often manipulating the fundamental behavior of its components. So now let's explore how serialization is explicitly handled in different languages, exploring its functionality, syntax, and unique features. Serialization. In PHP, it's accomplished using the serialize function, converts a PHP object or array into a stream representing the data and structure. The resulting byte stream can include various types, such as strings and objects. To illustrate this, let's consider a nodes application where user can save and retrieve nodes. We'll create a code nodes to represent each and handle serialization and deserialization. So this is a node. In a nodes application, when the user saves, we serialize the nodes using PHP serialize function. This converts the object into a string representation that can be stored in a file or database. Let's take a look at following code snippet that serializes the nodes class object. Okay, we have the variable node, and then we have the variable serialized node, which serializes the node variable right here. Now visit the link and enter any string to serialize or deserialize. For example, if you are the welcome to TryHackMe, and we'll generate the following output. We'll go over what it means. So let's try that. Proceed to the application. Let's decode the output. 05 nodes 1. This part indicates that the serialized data represent an object of the class nodes right here, the name of the class, which has one property. Okay. Next part S7 contents. This represents the property name content with a length of 7 characters. 1, 2, 3, 4, 5, 6, 7 characters. In serialized data, strings are represented with S followed by the length of the string and the string in double quotations, double quotes. Integers are represented with the I followed by the numeric value without quotes. S14, welcome to TryHackMe. So if you count the number of characters, including the space, it should be 14. And this whole thing is a string. Let's try that. Welcome to. Okay, we get exact output. We get the same output. The magic methods. PHP provides several magic methods that play crucial roles in serialization process. A few of the important methods are mentioned below. Sleep. This method is called on an object before serialization. It can clean up resources, such as database connections, and is expected to return an array of property names that should be serialized. Wake up. This method is invoked upon deserialization. It can re-establish any connections that the object might need to operate correctly. Serialize. As of PHP 7.4, this method enables you to customize the serialization data by returning an array representing the object's serialized form. Unserialized. This counterpart to serialized function, allowing for customizing the restoration restorations of an object from its serialized data. Moving on to the next. Python uses a module called Pickle to serialize and deserialize objects. This module converts a Python object into a stream, and vice versa, enabling it to be saved to a file and transmitted over the network. Pickling is a powerful tool for Python developers because it handles almost all types of Python objects without needing any manual handling of the object state. We'll follow the same nodes application in Python as in the PHP. Here's the code snippet from the app.py class. Alright, quickly the process. First, creating a node class. This class manages a list of nodes and provides a method to add node and retrieve all nodes, making it easy to manage the application state. Serialization or pickling. When a user submits a node, the class instance, including all nodes, is serialized using pickle.method. Transforms the Python object into a binary format that Python can later turn back into an object. Displaying the serialized data. Base system for encoding. Why use base system for? Serialized data is a binary and not safe for display in all environments. Binary data can contain bytes that may interfere with communication protocols. Like it is an encoding scheme that converts binary data into text. It uses only characters for transmission channels that support binary data. Encoding process. After serializing the binary data is encoded into the base64 string using the base64.bsys64 encode function. This string is saved to display in an HTML and easily stored or transmitted. Deserialization or pickling. Base64 decoding. When unpickling, the base64 string is first decoded back into the binary format using the base64.bsys64 decode function. Unpickling. The binary data is then passed to the pickle.loads function, which reconstructs the original Python object from the binary string. Now, again, visit the application link right here and try to enter the string welcome TryHackMe. It's on port 5000. This is the base64 encoded of the binary data. Okay, pickling. When the string is pickled, it is converted into a binary format that not human readable, which is this one, this part right here. This binary format contains information about the data type, the data itself, and other necessary metadata to reconstruct the object. The base64 encoding. The binary format of pickled data is then encoded into the base64 string, which may look like something like this, which is this part right here. In Exploitation formats, we've discussed how this critical functionality is implemented in PHP and Python. PHP utilizes the serialized and unserialized functions to manage the conversion of objects and other data types into a storable format that can be easily reconstructed. Similarly, Python employs the pickle module to serialize objects into a bystream and deserialize them back into their original state. Beyond these two languages, serialization is a common feature across various programming environments, each with unique implementations and libraries. In Java, object serialization is facilitated through the serialized interface, allowing objects to be converted into byte streams and vice versa, which is essential for network communications and data persistence. For .NET, serialization has evolved significantly over the years. Initially, binary formatter was commonly used for binary serializations. However, its use is now discouraged due to security concerns. Modern .NET applications typically use system.text.json for JSON serialization, or system.xml.serializations for XML tasks. reflecting a shift towards more standardized data interchange formats. Ruby offers simplicity with its own Marshall module, which is known for serializing and deserializing objects, and for more human-readable formats, it often utilizes YAML. Each language's approach to serialization reflects its usage, context, and security considerations, highlighting the importance of understanding and properly implementing serializations to ensure the integrity and security of data across web applications. Answering question. What is the base system for encoding input after you pick a string you got it in Python? What is the output of serializing the string you got it in PHP? What's the renowned binary serializations module used in Ruby? That's Marshall. After a thorough understanding of serializations across different programming languages, we will now transition into a critical aspect of cybersecurity, exploiting and mitigating vulnerabilities related to serializations. Before discussing the specifics of exploitation techniques, it's crucial to understand how to identify these vulnerabilities in the applications. Whether you have access to the code, which is known as white box testing, or not, black box testing. Accessing to the source code. When access to the source code is available, identifying serialization vulnerabilities can be more straightforward, but requires a keen understanding of what to look for. For example, through the code review, we can examine the source code for uses of serialization functions such as serialize, unserialize, pickle.loads, and others. We must pay special attention to any point where users' applied input might be passed directly to the functions. When auditing an application without access to its source code, the challenge lies in deducing how it processes data based on solely the external observations and interactions. This is commonly referred to as black box testing. Here, we focus on detecting patterns in server responses and cookies that might indicate the use of serializations and potential vulnerabilities. As a pen tester, padding a little tilde at the end of a PHP file name is a common technique attackers use to try to access backup or temporary files created by the text editors or version control systems. When a file is edited or saved, some text editors or version control systems may make a backup copy on the original file with a tilde appended to the file name and analyzing the server response. Error messages. Certain error messages can directly indicate issues with the serializations. For instance, PHP might throw errors or warning that contain phrases like unserialized or object serializations error, which are a giveaway of underlying serialization processes and potential points of vulnerability. Inconsistencies in the application's behavior. Unexpected behavior in response to manipulated input. For example, modified cookies or post data can suggest issues with how data is deserialized and handled. Observing how the application handles auto-serialized data can provide clues about potentially vulnerable code. Examining the cookies. Cookies are often used to store serialized data in web applications. By examining the content of cookies, we can usually infer the base system for encoding value in cookies, PHP or .NET. If cookies contain data that looks like base system for encoded, the coding might reveal serialized object or data structures. PHP often uses serialization for section management and storing section variables in serialized format. Here's ASAP.NET view state. .NET application might use serialization in a view state sent to the client's browser. A field name view state, which is base system for encoded, can sometimes be seen. Decoding and examining it can reveal whether it contains serialized data that could be exploited. So in this task, we learn how to identify vulnerabilities. In the upcoming task, we'll examine various techniques for exploiting the vulnerability. Now, answering the question, visit this URL, identify what is the user-defined function. Okay, first let's take a look at the source code. View page source. There's nothing here. Memory storage. There's nothing. In the cookie sections, there's no cookie sets. Then another way to look for is like append a tilde at the end. Remember this section? Where is it? Right here. Where you have no access to the source code, appending a tilde at the end of the PHP file. So right here we have the index.php file. We can try appending a tilde at the end of the file name to see if we can access in the backup file. There we go. We have a name, function hello TryHackMe serialization. That's going to be the name. Exploitation update properties. Updating properties of an object. In this task, we'll explore a practical example in PHP using a simple node sharing application as our own study case. Our node sharing applications allows users to create, save, and share nodes easily. Users can input their nodes into the application, which are then saved for future reference. Additionally, users can share the nodes with others, facilitating collaborations and information exchange. The information also includes subscription-based features, ensuring only subscribed users can access certain functionalities such as node sharing. You can access the website by visiting the link. Okay, let's go through how the application has been built. Defining the node class. The application has a nodes class, representing a node in our application. This class has three private properties: user, role, and is subscribed. We also have setter and getter methods to manipulate the isSubscribe property. Storing user data in cookies. When a user visits our application in the first time, it sets a serialized cookie containing the user data. This includes their username, role, and subscription status. If the user is a paid member, meaning its subscribe variable is true, they are allowed to share notes. Exploiting the vulnerability. In this step, we'll illustrate how an attacker can exploit the vulnerability by modifying the serialized cookie value to get unauthorized access to the share nodes. We have a serialized cookie. After decoding the base SysFor encoded cookie value, we obtain the following serialized representation nodes of the object. As we already know, in PHP serialization, the class name is prefixes to the property names in case it is not public to ensure uniqueness and help with deserializations. This is part of how PHP handles object serializations and deserializations internally. When an object is serialized, PHP stores the object's properties and class name. This ensures that when the object is later deserialized, PHP knows which class to instantiate and how to assign the serialized data to the object's properties correctly. So let's break down the serialized node into its components. We have all 5, nodes 3. This represents the object with the same class nodes, which has 3 properties. This is an object called nodes, which is 5 characters long, and then it has 3 properties. And this is the list of the properties. The first property is user, which is a string with 4 characters long. The value of the first property user is guess, which is a string of 5 characters long. The second property, which is role, whose values is also guessed. And the third property is subscribe. Is subscribe, if you count, is 12 characters long. And its values is assigned as 0, meaning that the user is not subscribed. Okay, let's take a look at the cookie section. Right here, we have this one. So, exploiting the vulnerability. In the current section scenario, when the user would like to share a note, they get the following pop-up. Okay, please subscribe. Link to my blog, test.TryHackMe. Please subscribe. Now what's happening in the backend? The backend PHP code validates the incoming cookies, deserializes it, and then validates whether the user is subscribed or not. Our main task is to bypass that. Suppose an attacker intercepts these serialized key values and verifies the subscribe property from true. The attacker can manipulate the subscription status without legitimate authorizations by changing the value serialized data. Then modifying, the attacker would make SysFor encoded serialized data again and replace the original cookie values with a modified one. This would grant them unauthorized access to share nodes on the platform, bypassing the intended subscription restrictions. Okay, let's try it. So we have the encoded values of a cookie. Open it up inside the chef. So it may take a while. Here we go. So we have the string right here. As you can see, it's URL encoded. So the first thing I have to do is URL decoded. Pass first. Okay. And then because we know it's base 64, which is gonna be decoded from base 64. And this is a string we have. Now what do? We copy the whole string right here, the serialized string, paste it here, modify the values from 0 to 1. Now we're gonna have to encode it. So to base 64. Good. And then we're gonna be URL encoding the string. So URL encode right here, encode on special characters. There we go. So this is the new values of the cookie string. Double click this one, replace it with a new one. And now try to share the nodes. Yep, you got a flag. What is the default role value once the user loads a node application? Let's guess. Exploitation, object injection. Object injection is a vulnerability that arises from insecure data serialization in web applications. It occurs when untrusted data is deserialized into the object, allowing attackers to manipulate the serialized data to execute arbitrary code, leading to serious security risk. In this task, we'll explore how object injection works and demonstrate its impact throughout a simple PHP code snippet. As we know, the vulnerability arises from the process of serializations and de-serializations, which allows PHP objects to be converted into a storable format, serialization, and reconstructed back into objects, the serialization process. While serializations and deserialization are useful for data storage and transmission, they can also introduce security risks if not properly implemented. To exploit a PHP object injection vulnerability, the application should include a class featuring a PHP magic method, like the wake up or the sleep methods, that can be exploited for malicious purposes. All classes involved in the attack should be declared before calling the unserialized method. So for example, let's consider an index.php code snippet that shows the serializations and deserialization using the serialized and unserialized methods. The code accepts the get parameter decode or encode and converts the user provided values accordingly. So what does it mean? So we visit this website and now it will send the input hello TryHackMe with an encode parameter. We'll get a following output. Let's try it. Okay, we see that the code includes a file called test.php. From a source code review or considering whether the framework is open source, the pen tester knows that the test PHP contains a class called malicious user data as shown below. Over here, you see the required test.php. By the way, this is coming from a white box testing point of view, meaning that you get access to the source code. That's why you know that the test.php exists. From the black box perspective, it's almost impossible unless that the test.php is displayed somewhere in the front end that can be seen by attackers. Otherwise, it is almost impossible to know the existence of this text.php. And because we have access to the source code, we know that this file exists. And then when we take a look at this file, this is the function inside that file right here. PHP class malicious user data, everything. In the above code, through insecure deserialization, it's possible to manipulate the properties of an object, including entering the command property of the malicious user data class in the above code. This can be achieved by crafting a specially crafted serialized string that contains the desired property values. For instance, if we want to modify the command property to execute a different command or connect to a different server, we can serialize the object with the desired property value and then inject it into the variable unserialized function. This way, upon deserialization, the manipulated property value will be loaded into the object. It is important to understand that during insecure deserialization, you can't directly update the definitions of the wakeup method itself. The wakeup method is a part of the class definition and remains started during the deserialization process. However, what you can do is modify the behavior or properties of the object within the wakeup methods. This means that while the method's definition remains constant, its actions upon deserializations can be manipulated to achieve different outcomes. Now that we understand the basics, it's time to prepare the payload. As discussed earlier, calling another class is normal feature in PHP, and you can view the code of that file if the target website is using open source code. The code in index.php unserializes the input without performing any sanitizations. What's the options here? What if we modify the class malicious user data and modify this command attribute such that when the wakeup function is called, it will be called with the attacker provided values. So first, let's create some PHP code on attacker box we're going to copy the whole right here and then open up a terminal. Let me enlarge the terminal. Okay, terminal, that's not PHP. Paste. No, we're gonna make some adjustment to the code snippet. Over here, we're going to add our attacking box IP address, which is 10.10.2.14.2.50 and 7. Double check. Cat index.php. All right, that's good. Okay, here's the explanation. In the above code, the webcam functions of the malicious user data class. Okay, in the test.php file, we'll execute a reverse shell command using netcat to listen into the specified IP address, which is our attacking IP address, and the port number, which the E flag to execute the bin bash as a shell. Once you create the file, execute it through the php index.php through the terminal. This will return the base system for encoded serialized object of the malicious user data class. Okay, this is how the base system for encoded string looks like. And then we start a netcat listener of port 444 on our on our attack box. Now it's time to exploit the insecure serializations by decoding the shellcode by visiting the URL, this URL right here, without generating the shellcode. So remember, on this application, it allows you to either encode or decode a string. So over here, the parameter is encode, meaning that this one will encode the string hello TryHackMe into a base system for encoded string. Now vice versa. Let's say if we copy these values and then we change the parameter to the code and replace the values, we get the base system for decoding right here. Data user private hello TryHackMe. Okay, similarly with the same concept, we're going to generate a base system for string right here by php index.php. We're going to copy this one and then paste here. Okay, before we hit enter, we have to set up our netcat listener. Netcat-l-n-ep4444. Okay, now we can just actually click enter. And there should be a shell connection, a reverse shell connection. Here we go. ls, we have flag php. Let's see what user data.php. We can see flag.php. And the flag is a shell. Alright, so that's how it's exploited. In the upcoming task, we'll understand the issues that allow the attacker to exploit the vulnerability and how we can secure it from a secure code perspective. What is the flag value after getting the reverse shell? That's it. What is the output of who I am command after getting the shell? Who am I? Did I say who I am? Maybe, sorry. Who am I? Dash data. So 1, 2, 3 data. Cool. Automation scripts. Automating script during pen testing is essential for efficiently identifying and exploiting vulnerabilities in the web applications. In this task, we'll explore the one tool called PHPGGC or PHPGGC for short, that plays a crucial role in this process, automating the discovery of insecure deserialization vulnerability. PHPGGC, akin to Ysoserial in Java ecosystem, helps security professionals assess the security posture of PHP applications and mitigate potential risk. PHPGGC is primarily a tool for generating gadget chains using PHP object injection attacks, specifically tailored for exploiting vulnerabilities related to PHP object serializations and deserialization. PHPGGC provides a library of gadget chains for various PHP frameworks and libraries. These gadget chains are sequences of objects and methods designed to exploit specific vulnerability when a PHP application unserializes user-provided data. Payload generation. The main purpose of PHPGGC is to facilitate the generation of serialized payload that can trigger these vulnerabilities. It helps security researchers and penetration testers create payloads that demonstrate the impact of this insecurity serialization's flaws. Payload customization. Users can customize payloads by specifying arguments for the functions or methods involved in the target chain, thereby tailoring the attack to achieve specific outcomes, such as encoding. You can download PHPGGC from its GitHub repository, or use the version already available on the attack box. The install version contains a few gadget chains, sequences of PHP objects, and the method codes designed to exploit deserialization vulnerabilities. These gadget chains leverage PHP's magic methods to achieve various attack objectives, such as remote code execution. To list all available gadget chains, you can use the -L option with the PHPGGC, which will name, version, tab, and the vector for launching a specific task. Additionally, you can filter gadget chains based on their capabilities, such as those targeting particular PHP frameworks or achieving specific exploit techniques, using the -L option followed by the filter keyword, Drupal, Laravel, etc. This allows you to select appropriate gadget chain for the exploitation scenario. All right, let's take a look at it. So we go to opt PHPGGC, ppggc.l, PHP and PHPGGC-L. Okay, we have a long list. So we have the name, we have the version, we have the type, and then we have the attack vectors. And let's say we're interested in this one, we can also use a -L flag to take a look at it. So it's going to be PHPGGC-L, and then paste the name. This is how we filter the versions or the name. All right. For example, the output for cake PHP RCE1 means that the gadget chain's name cake PHP RCE1 exploit an RCE vulnerability in the cake PHP versions up to 3.9.6. This vulnerability allows attackers to execute arbitrary commands on the server by leveraging the disrupt magic method. So cake RCE1 right here, version is anything up to 3.9.6. And the ability is remote code execution, which focuses on the magic method called destruct. Okay. Exploiting a web application. As a pen tester, we're focusing on leveraging a website to exploit a known vulnerability identified under the CVE 2018-15133. And this is going to be a link. In leveraging framework through 5.5.40 and 5.6 through 5.6.29, remote code execution might occur as a result of unserialized code on a potentially untrusted XSRF token value. This involves the decrypt method in Illuminate encryption encrypted .php file and petty broadcast in GagaG's Laravel RC chain.php in PHP's GGC. The attacker must know the application key, which normally would never occur, but could happen if the attacker previously has privileged access or successfully accomplished in previous task. So there are 3 steps. Step 1 requires the app keys from Laravel, which the framework uses to encrypt the XSRF token. Second, we use a PHPGGC to generate an unserialized payload, executing a command. This is considered a complex task, and the tool comes to the rescue. And step 3, finally, we must encrypt the payload using the app key and send a post request. This usually varies from framework to framework. In our task, the focus will primarily on step 2 and understanding how PHPGGC will assist a user as a pen tester. Visit the vulnerable Laravel application at this IP address. So 8089. Let's close this one. As a pen tester, we can identify the web application versions through multiple techniques. You can visit the information gathering and vulnerability scanning module to learn about this in detail. The Laravel application version is 5.6529, which is vulnerable to this CVE 2018-15-133. Now we go over detailed step-by-step in exploitation. For the first step, we acquire the app key through any attack vector, such as social engineering. You can get the app key by visiting this one. For your convenience, this page will also provide you with the first payload that has the who am I command. So usually we have to go through a bunch of steps in reconnaissance and social engineering to get the app key. But over here, TryHackMe has already provided us with the app key. So let's go and grab it. Get key. So this is the app key. Let's open a new one. For the second step, we need to identify the payload we can use. We run PC Laravel because the application is using Laravel, so of course, obviously we'll have to use it, Laravel. And we know the version is 5.65.29. Where does it stand? Everything stands here. Helps. So what do we do now? Moving forward, we can generate payload using various gadgets. Each gadget has its relevancy and utilizes different classes during the deserialization process. We'll use RCF3 in this example and can generate payload by typing the command system.hom for the basis for encoded payload. A non-encoded payload is shown below. Okay. I'm not pretty sure why they picked the Laravel RCF3 but not any other methods. But in reality, when you present it with several options, you gotta try them all. Some may work, some don't. So it's all about trial and errors. We have several options right here, and we were told to use this one. So this is going to be a command. That should be our system.hom. So let's try the non-encoded version first. PHP. Nope. It looks exactly like this one right here. Okay, so let's get the basis for encoded version. Okay, just simply add the flag -b. Here we get it. Copy. Let's go to subshift. And then have URL encoded. Okay. URL. This is the URL encoded version. The breakdown of the payload: illuminate, broadcasting, penny broadcast, and then the channel manager. The first one, penny broadcast. This class handles event broadcast in Laravel. Here is primarily a vehicle for carrying the nested malicious object. And the channel manager is the object manages notification channels. We manipulate it into inject arbitrary code execution through its properties. Apps typically would with reference to the application service container. We misuse it to hold our command who am I. We also manipulated the default channel and the customer creator's properties that are twisted into create a scenario when a PHP assert function is called, executing a code path to it. A little bit complicated. Let's move on. As we already know, Laravel initially implied encrypted and serialized cookie to secure storization and CSR token later, using the same methodology for both. If you visit a vulnerable app, you can see the encrypted serialization and serialized cookie as shown below. Okay. The basic idea was to avoid tampering with data from bad actors, but nevertheless, they did not realize that even such strong security mechanism could be breached through executive serialization. So the application has the anti-cross-site forgery token right here. And this value is encrypted. Now that we have the app key and the payload, it's time to create an encrypted CSRF token. For the sake of this role, we have prepared a PHP script that would take the app key and the payload as arguments and return the encrypted token. You can access the link like this. For convenience, this URL has already the URL encoded key and first payload with the who am I command. Understanding the encryption mechanism of our framework like Laravel or WordPress is a simple task, but currently it's out of scope. Alright, so let's try it. So this is going to be the payload. And we are looking for the app key, which can be found here. Let's use the URL encoded version. So we have two parameters, app key right here and the payload right here. Okay, looks like everything is good. Okay, when pen testing web framework like Yi, Cake, PHP, and Laravel, it's essential to understand that each framework has unique routing and encryption mechanisms despite on them being built on PHP. These frameworks are designed with different architectures and security implementations, which means that A vulnerability like RC3 Laravel specifically explains Laravel service containers and serialization's behavior would not necessarily apply to WordPress or other PHP-based systems. WordPress, for instance, has a different structure and does not use Laravel-specific class and methods. So an exploit tailored to Laravel architecture won't directly work on WordPress. Now that we have the encrypted token, we can do a post request using a CSRF token as shown below to execute a command. The payload results will appear in the start of the code. So in order to get the encrypted token right here, we have to run this URL that we prepare. We're going to copy this one, paste it, and we have the encrypt token. So what's the code command? Code command is target machine, post request, and then the header is going to be the token. Let's do it. So curl 10.10.245.85 post XSRL token. Copy the whole thing right here. Let's try running it. Okay, something's wrong. Let's see what's going on. XSRF token. Okay. Crew 10 240. My bad. 245. As you can see right here, the response is very long, and we're only interested in the first two lines. Why? Because as it states right here, the payload result will appear at the start of the code response. So because of that, we're going to pipe the output into another command, which is head, showing the first two lines. Okay, let's try again the command and then pipe the output to the head command. And we can see, who am I? Root. I am root right here. Cool. So that's how we exploit the vulnerability using the PHPGGC. Pretty much complex, right? I know, but eventually when you keep using the tool, you'll be able to get used to it and find it easy to manual and navigate around. So Ysoserial for Java. So Ysoserial is a widely recognized exploitation tool specifically crafted to test the security of Java applications against serialization vulnerabilities. By the way, I don't know if I pronounce it correctly. Your serial or Ysoserial, I don't know. It helps generate payloads that exploit these vulnerabilities, making it an essential tool for attackers and penetration testers who aim to assist and exploit applications using Java serializations. To use a serial, an attacker would typically generate a payload with a command such as this one, java-jar, serial.jar, and then the payload type and a command to execute. The command type, the payload type is type of exploit, and the command to execute is something like who am I, or ls, or a system command that connects to your netcat listener. For example, using the commons collections one, payload type may look like this: java-jar, serial.jar, and then command collections one. And then here you try to execute a command system, a command line called calculator. I believe it's on calculator. Yeah. This command generates a serialized object that will execute the specified command when deserialized by a vulnerable application. Okay, so serial can be downloaded from this GitHub. What is the vector for exploiting the code igniter for F1? As per the PHPGGC. Let's copy this one. PHPGGC.l. This one. ToString. What is the output deployment command of that was root? We found it. What is the output of user uname -r command for the vulnerable Laravel application? So we read going back to the step. Let's see. Where do we start? So first we have to generate the basis for string for the command uname -r. So let me sum up the step. First, generate the payload, which is base 64 encode from PHPGGC for the command uname -r. Okay. Then we use the generated payload plus the ACK key to get the encrypted token value for the XSRF token. And then once we got the encrypted values for the token, we're going to perform a curl command using a post request with the encrypted value for the XSRF token. So these are going to be the steps that we're going to perform. Let's do it first. Generate the payloads base system for encoded from the PHPGGC. So let's copy this command. Name dashboard. So PHPGGC and then -b. I believe we're going to use the same thing, Laravel RCE3 and then system union dasher. Now, if you don't remember the command, just go back to this step right here. It's just a command that we have. So system, who am I? Over here, I have the system, and then the command is union dasher. All right, and this is going to be the base system for copy. Let's try. I'm going to append underneath right here. This is the value. Use the generated payload and app key to get the encrypted value. So this one is going to be the same all the way here, and the payload is going to be different. So this is going to be our new payload. The app key is going to be the same. We have to first URL encode this and paste it here. So copy this one. And we have the encrypted value for our token. Now that we have this one, we're going to use the same command. So again, this stays the same. Curl the target machine, post request, the token, and we only have to change the token value. Copy the whole thing, paste. Let's try again. Pipe it into the head command. Only display the first two lines. Okay, so we get this one 0505 15 1075 AWS C. Yep, that looks correct. Okay, cool. Mitigation measures. Mitigating the risk associated with insecure deserialization is paramount in ensuring the security of application. By implementing effective defense measures, organizations can significantly reduce the likelihood of exploitation and mitigate potential damage. We will discuss this from the perspective of a red team or pen tester and the secure code perspective. Conduct a comprehensive review of the application's serialization mechanisms. Identify potential points of deserialization throughout the code base. Vulnerability identification. Use static analysis tool to detect insecure vulnerabilities. Look for improper input validation, insecure libraries, and outdated dependencies. Fuzzing and dynamic analysis. Employ fuzzing techniques to generate invalid or unexpected input data. Use dynamic analysis tools to monitor the application's behavior during the runtime. Error handling assessment. Evaluate how the application handles errors during deserialization. Look for potential error messages or stack traces that reveal the system's detail. Secure code perspective. Avoid insecure serialization formats. Avoid using inherently insecure serialization formats like Java serialization. Choose safer alternatives such as JSON or XML with robust validation mechanisms. Avoid using eval and exec functions, as they can execute arbitrary code and pose a significant security risk. Implementing stringent input validation to ensure that only expected data are accepted. Apply output encoding techniques to sanitize data before serialization. Follow secure coding practices recommended by security standards and guidelines. Adopt principles such as privilege, defense in depth, and defaults. Establish secure coding guidelines specific to the programming language framework. Ask the question, is it a good practice to apply use without knowing? Conclusion. In conclusion, the room in insecure deserialization has provided a pro understanding of this critical security vulnerability and its impact on web applications. We started by exploring the fundamental concepts of serialization and insecure serializations. We then delved into various serialization formats used in different languages like Python, Java, PHP, or Ruby. We then into various serialization formats used in different programming languages to understand the diverse manifestations of this vulnerability. Next, we learned how to identify insecure serialization vulnerabilities within applications. Through practical exercises, we explore techniques including updating properties and object injection to comprehend the multifaceted of attacks leading to remote execution. Finally, we discussed the mitigation measures to secure applications against these vulnerabilities and review automation scripts to streamline the identifications and remediation process. This room has equipped you with knowledge to identify, exploit, and mitigate insecure civilizations vulnerabilities, strengthening your overall security posture. Alright, that is it for the room today. I hope you learned a lot from room about serializations and insecure serialization vulnerabilities. If you have any questions, as usual, feel free to reach out to me. And I'll see you in the next video. Thank you. Bye.